Hey guys, Kool-Aid here. That'll be the last time you hear me say that. I'm going to change the name of my channel, guys. It's going to be called Wages World. And the reason being is because the new law that was enacted in the terms of service with YouTube is going to change on the 10th. They're trying to gear traffic away, keep people from putting, like this picture right here you guys got that you can see. Kind of looks like it could be geared towards a child. So they're trying to get rid of that kind of thing to keep inappropriate content away from the children. And it's across all platforms, not just YouTube. Okay, so if somebody violates that or whatever, and I would imagine it would have to be something pretty severe. Like some of these gaming channels that do the kid content, really not really kid content, but do game content. A lot of kids go watch. They got some of the filthiest mouths I've ever heard. Okay, so I could see some of those channels may have some issues. I could probably leave my stuff exactly the way that it is. Name, everything, and would be just fine. But I'm not going to take that chance because we all know how that goes. Now, also, I've heard a lot of people talking about the part of the terms of service commercially viable. YouTube has the right to terminate your channel at any time if you're not commercially viable. In other words, if you're not making YouTube any money. Okay, if they don't see your channel as being profitable to them, they can kill your channel at any time. People are freaking out about this, and the reason why that they shouldn't be is because that has always been there. Okay? It has been there since day one. I don't know why people are grabbing a hold of it this time. They may have changed some verbiage in there a little bit. But the terms of service is really about the COPPA law, not the commercially viable thing. I don't monetize my channel. Okay, guys? So if they decide to start shutting channels down for that, Blue Kool-Aid or Wages World now will probably just go away. I wouldn't have a choice. They would probably just kill my channel. But I don't see them doing that for a lot of reasons, because if they start doing that, then they're not going to have a platform at all, because there's a lot of people out there that don't even do content at all. So they would actually be killing their customers off. So it just wouldn't make any sense. They just put that in there for the extreme case. If they don't like you or what have you, they can kill your channel anyway at any given time. And we all know that anyway. We can all fight it all we want, but let's face the facts. If they didn't want us up here, we wouldn't be up here at all. So, but anyway, I'm going to move on from that. We'll go ahead and talk about what we really should be talking about. So, okay, guys. We just took a big smack across the face here with a very, very high dense wave of charged particles. It came out of nowhere, and it was one single shot. So I'm not really sure what to relate this to. It did not come from the sun. I can guarantee you that, unless there was a small flare or something that popped off that we couldn't see. And I'll talk about that a little bit more here in a minute. Chances are this was probably most likely a cosmic ray burst. I don't know for sure, but I will say this. Our geomagnetic activity level, our storm levels, is extremely low. It's in the basement again. Okay, so that would tell me that, extended periods of time of low geomagnetic activity means that more cosmic rays get through. Okay, so when we bottom out, that's not good, and I've talked about that before. But usually it takes a day or two for that to really kick in and take effect. But it doesn't say that we still couldn't have stuff hitting us anyway. And I'm going to show you what I'm talking about here, because this actually kind of surprised me just a little bit when I seen this. Okay. This also gave me a good opportunity to show you guys what I mean about how our bow shock doesn't go away. So, as you can see, that's just, guys, when we see that stuff behind us like that, especially on this model, it's very hard to, well, I don't want to say we don't want to trust it, but we can't trust it as much as what we can see in the front. Because these tools are out there, the satellites, they're designed to see what's in the front, not behind us. Okay? And again, these things aren't perfect either, especially these. Okay. And as we're doing this, you're going to see what I'm talking about. So when you basically what I'm saying is when you see those things in the back like that, don't get all crazy about it unless it looks really really strange. Now, when I start talking about this stuff, I usually when I see it, I can kind of see now what is actually like normal conditions and what it looks like when it's really not that big of a deal. So I start comparing in my own mind what's normal and what's not. That's usually what I'm comparing. Okay, not necessarily the actual shape of the signature we're seeing, but the actual, does it look normal or doesn't it? That's when I get keyed off to these. Now, at first I didn't, because I just didn't know what was normal and what wasn't. But as we go through here, you're going to see it's pretty easy to see. Now, see, that was a smaller one right there. See that? We didn't react very much. That was, and these things are 5 hours apart from one another. And I wouldn't even call that a big burst. I don't know what that was. That could have just been a small increase in solar wind. I don't know. But as we get up here towards like 7:30 UTC, you're going to see right about there. See that? Okay. And it only happened once. That's what I'm trying to say. So that's at 8:02. 8:06. Now this time here says 8:06, and it's talking about UTC. This is actually exactly an hour ahead of UTC. I don't know why this tool is doing this right now, because the other UTC, the other models that show UTC are showing this at this. In other words, this model is an hour off. Now, see, yes, the other day, guys, when we were talking about the bow shock possibly being down and all that kind of a thing, this is exactly what it looked like. If you guys remember. Okay, see, look at that. It's not down. Okay, because if it was down right there, and then the very next frame, we see that, what would you do? I mean, if the bow shock wasn't there and that hit us like that, that could be some serious issues, is what I'm trying to say. Okay, and I already explained to you guys, you can't, if the bow shock, you have to have one of two things can't be there. You can't have a magnetic field or solar wind. You got to have them, they're both there constantly. Okay, one of those would have to go away to not have a bow shock. That's really as basic as it gets. Not to say that our bow shock can't change shape, doesn't move up, out and about. It doesn't change in strength, because it does. Okay, everything affects all of that. And I went into that in my last video. I'm not going to do it again today. But as you can see, and what we look at here is the solar wind speed. When we see a big slough right there, and remember guys, when we're looking at the colors of this, we're talking about density. The colors are showing you density, how dense the material is there. That's all those colors are showing you. Okay, there's the wind speed, 359. That is not high. That is very, very normal. Okay, so here's the density meter, and this does change too, okay guys? So don't always think it's negative 1.39 to positive 2.15. Okay, they changed that when things are way off the chart. Because if they didn't, then you wouldn't be able to have a graph. Things would be so far apart from each other. That's why they changed those. Those numbers don't stay the same. But I guess the main thing is to know, what's in the middle, how far away from it is from normal than what it normally is. That's the biggest thing, okay? Now, I can tell you right now, this was a high, dense smack. And it was just one little smack. It's like we got backhanded, I guess. I don't know. Did it have any effect? Well, I do know that within 5 minutes of this shock wave here, I don't even want to call it a shock wave. Okay, it's just a little, I don't even call it little because it wasn't really little. Now you can see the wind speed bump up to like 746. Okay, it's about as high as it got. 740. Did it get to 8? No, 776. Okay, that's about, oh, it did get to an 8. Look like, yeah, it did. Right, yeah, it did. Right there, 841. Okay, now granted, that's actually pretty high. Okay, that's what we would see during like a geomagnetic storm. or a solar flare, or a CME that come across this, all those kinds of things, right? But this did not last long enough for any of that to be. Okay, so what I'm saying is this did not come from the sun. I can't stress that enough. These tools out there, guys, you got to keep in mind, they assume that it's solar wind. They assume it's charged particles coming from the sun. The fact of the matter is, these tools cannot differentiate what the source is of these charged particles. Okay, they cannot tell you that. They don't know. All they can tell you is how fast they're moving, how dense they are, and, you know, a host of other things they can tell you, but they cannot point to a source. And that's the problem, because if we could point to a source every time, there would be no question. Okay, but this did not come from the sun. At least from what I can see and what I can gather. All I can tell you is that that was a pretty hefty little smack, and it goes away real quick. Just a bam and gone. Okay, conditions went straight back to normal, and you know, and this is a really good chance for me to show you guys what I talk about compression and rapid expansion. Okay, because this is what you're going to see. You're going to see our bow shock compress right about. Let's get to the time. Here it comes. See that? Look at that. See how fast it compressed? All right. That whole event only lasted like 20 minutes, if that. See how far it compressed? And like I said the other day, I'm going to say it now. That's inside our satellite line. That dotted line right there is the orbit of our satellites. So when that bow shock does get down into there, that means our first line of defense is actually inside that line. So that means anything coming from this way doesn't have that bow shock to protect it. Okay? That's why we get concerned a little bit when the bow shock gets compressed. Okay, so as you're going to see, every time you get a massive compression, you get a rapid expansion, and usually it's pretty massive. See that? See how fast it expanded back out? We push back, guys. That's what that is. Okay? You guys remember being a kid and you put your hands up to one of your friends and you guys start pushing against each other and you're pushing real hard? What happens when one of you guys decide you want to step out of the way? Well, the other guy just lunges forward, right? That's exactly what happens here. We're getting pushed, and then finally that solar wind or cosmic ray burst or whatever has moved out of the way, but we're still pushing just as strong. Okay? And then we push on out a little bit, then we come back to normal. That's what happens here. Okay? See that? You can see it. It just explodes out. And then it goes back to pretty normal conditions. Really quick like. And like I said, guys, it only lasted 20 minutes or something. The whole thing. And again, so did anything happen? Well, let me show you something. Alright, guys. This is what I'm talking about right here. Okay? This is why we talk about solar wind, cosmic rays, and what can it do? How is it affecting us? I really think that big smack we just took probably was the straw that broke the camel's back and allowed these earthquakes to happen. Okay? When I looked here a minute ago, that top one, that 6.0 in Chile, wasn't there. This one down here, 729, was. Okay? And that's the exact time that we got hit with that, whatever kind of energy that was, wherever that came from. I can tell you, like I said a minute ago, it was high dense, and I'm going to show you that here in a minute, how high it was. Okay? So, you know, as you can see, I thought that this first one, the 5.4 in Chile, was going to be the big one, the bigger one out of all of them, right? That would happen from this. Well, there was a 6.0 an hour and a half later. Okay? And, well, most of these are green. We'll look at this real quick and see where this is located. Let's go to the interactive map. Okay, that's where it's located, guys. This is in South America. This is on the Ring of Fire. If you guys don't know what that is the whole ring here around the Pacific. Okay, most people know what that is. If you don't, you do now. So, but that's where it was located. It does look to be like it might have been offshore, maybe, which might not be the greatest thing in the world. So what we'll do is we'll go down here and see if there's any kind of tsunami, anything. I'm not seeing anything tsunami, okay? So that's good, okay? And you can look here. Remember I showed you guys here the pager part? It looks like everything's pretty much green here. We can, let's just look at it real quick, see what we got. Yeah, so I wouldn't think that there would be any kind of deaths or anything from this. It may not be a very populated area. Obviously, that's offshore right there. But it looked like that other one that happened before this one, I'll tell you what, let's, is it there? Nope. Let me back out of this here for a minute. Hold on just a second, guys. Okay, guys, this one right here is the one that happened before the 6.0. I just went and looked. We'll look at it together, I guess. As you can see, it's really close to the other one. Okay, they're just a few miles apart there. It looks to be nothing big is happening from this. Okay, thank God. But let's not forget that was a 6.0 and a 5.4, basically in the same area. Wasn't the exact same spot, but they were an hour and a half apart. And for me, most of the time you see the big one just pop, right? Well, this time it looked to be a little different. And we do see sometimes a slightly smaller one before the big one sometimes. It's not like unheard of or anything, but from what I can see, from what I usually watch, and I'm not the best person to come to for earthquakes, guys. I say that all the time because I just don't know enough about them. But the ones that I've seen, I've heard more of. We've heard of foreshocks. We've all heard of aftershocks. So the 5.4 might have been a foreshock. That's a pretty high foreshock. But if you look down through here, guys, you got Afghanistan. There's one in Kansas. That's probably from fracking operations, I would assume. Japan. And something else up here on these top two. One thing that is that did strike me here is they're both pretty shallow. Okay. What they do here, guys, when they show I do know this, that they show a depth over here, if they don't have time to actually figure out what the exact depth is from the tools, it when you first see it, it automatically goes to a default of 10 kilometers. So you got to give it a few hours to really get the correct depth. This one, it's not at the default, so they must think that this is deeper. But that first one they left at 10 kilometers, so it probably was about 10 kilometers down, which is very shallow. So the shallower they are, the more we feel it. But yeah, that very well could have been a direct result of what I just showed you guys. Okay, guys, this is the other Magnetopause model. This is going to be able to show you what I was talking about with the bow shock doesn't go down. And you're going to see a big hit here, guys. That's what you're going to see. You're going to see the same thing I showed you a minute ago on the other model. See that? Boom. Okay. We're going to go ahead and advance through here. I already showed it to you guys. But watch this one. Okay. This is the density model. I'm going to pause it when it gets to the point where I want you guys to see. All right. I'm going to wait for it to do its little hit. And then what it does after the hit, you will see exactly what I'm talking about. If this thing will ever get to it, it's coming. Okay, here it comes. Okay, you guys seen how big of a hit that was, right? So I'm going to, right there. Okay. Now, do you see what I'm saying here, guys? Now, what I'm showing you is we took that big hit, but look, see the difference in density? See the lighter color here? That's showing you that bow shock is still there. Okay. We are open out here in the front, but the bow shock is still there. It looks to be open. I'm not going to say that it's open. That's just, on this chart, the darker colors means it's higher density. So that's higher dense particles. And again, this over here on the right, that we took a hit, guys. But you can clearly see that our bow shock is still there. It didn't go anywhere. Okay? It might have compressed and moved and all those kinds of things I just talked about. But it's still there. But the thing of it is, guys, right here, you can see how that denser material did make its way in some. And around, you can tell, if you look here, because this is the Z cut that you're looking at here on the right. That's a top-down version. So basically what you're seeing is this density probably has snuck in on the poles. Got into our atmosphere that way, I would assume. Some of it probably just came right on at us. But it looks to be like a lot of it came in through the poles, which it does a lot anyway. We see that on one of the other models I don't show you guys very often. Maybe I'll start showing it to you guys. But but anyway, just know that, okay? So, and also check this one out. That's the beginning of it right there, I think. That's at 535. Okay, watch this one. This one really shows it really well. Boom. Look at that. You guys see that? But as you can clearly see, our bow shock didn't go anywhere. It got pushed back and then rapid expansion. Okay? I know I'm driving that point home, but I really want you guys to understand that because it can really strike some fear into people. But I do think that probably had something to do with those earthquakes, guys. Okay, guys, this is the Australian model. Now, I like looking at this one a lot because it does give you kind of a better, a better understanding or grasp of what we're actually seeing because it is so simple, okay? This is basically, I explained this the other day, but this is basically showing us what I just showed you, but it's showing you in a different visual, okay? If you look at this, you can see the satellite line. Okay, it shows you all the satellites that it's showing. Okay, here's the key down here if you guys want to go look at it. All right, there's a lot of satellites. It plots a lot of satellites there. The other ones don't do that. Usually they just show you a couple, 3, sometimes 4. But this one seems to show quite a bit of them. But what I like about this one is the simplicity of what it's showing you here. Do you see this right here? It says proton density. That's what we're talking about when we're talking about density of particles or charged particles, the density of them. See, it says 3.9 right there, protons centimeters cubed to the third. What it's telling you there is, like I said, how dense it is. That's actually a pretty normal number. 3.9 is. But let me show you something. Okay, when we took that hit, I'm going to pause it. I think I passed it. Okay, let's just go forward this way. Sorry it's taking me a minute here, guys. Did it not do it? All right, I'm going to pause. Okay. This is what I'm going to show you. Okay. I just showed you 3.9. Somewhere between 1 to 3 is typically normal for a density reading. Look what we got here. 124.9. Okay, and the other models confirm it. All right, and it only lasted, watch this. This is a minute time frame. It's giving us a capture every minute. Watch this. In 1 minute, 2 minutes, 3 minutes, it's back to normal. That's how short-lived this was. Okay. 124. Boom. Now, what I really find really interesting, okay, at 627, you go 1 minute. 628, it went from 4.3 to 124. 120 increase on the density. That's crazy. That was a very intense, so that's what makes me think it was probably like a cosmic ray burst. I guess it could have been from our object, but typically that comes at us more like a solar wind does. It's more of a long-lived event when that happens. It doesn't typically just get one little small little burst. So, I mean, I would be curious to see what other people think about this, because I really think that this is probably just it could be a cosmic ray burst. It could be anything, guys. All I know is we got hit with something there, high dense material, and I do think it probably has something to do with cracking off them earthquakes. So yeah, guys, I am going to go ahead and end the video here. I actually planned on doing some other stuff here, but I'll do it in my next one. Just remember, guys, I'm going to change the name of my channel to Wages World. And we'll talk about that a little bit more in my next video also. But yeah. So unfortunately, this will be the last time you see that picture. It does. I really don't want to do it, guys, but I've been Blue Kool-Aid for a very long time. Guys, and just so you guys know a little backstory on that real quick. I used to wear, I used to weigh over 500 pounds, okay? I had bariatric surgery, and I lost over 200 pounds. So, yeah, I lost a fat guy, and I'm still a fat guy. But when I was that big, I would wear a big red shirt, right? And I would call myself the Kool-Aid Man. That's just how I dealt with it. I turned it into humor and stuff. But that's where that name came from. When I went to do my YouTube channel, the red Kool-Aid was taken. Kool-Aid Man itself, that whole genre was just taken. I couldn't get that name. So I went with Blue Kool-Aid, and there it was. So that's why I became who I am here as far as my identity on this thing. But just remember, guys, that's what you're going to see from now on, from the next video forward. And I already explained to you why. Just look up Kappa. There will be a model update here, guys. I got some Three Dog Night and some, what else do I got for you guys? Old Beatles song. And I can't remember. There's a third song there too. Yeah, check it out, guys. But anyway, God bless. Yeshua saves. And for the last time, I'm going to say it. You can drink this Kool-Aid.